I'm going to present experiment 3 from the neural networks regarding MLP backpropagation. It is implementing an MLP for a non-linearly separable data classification task. In this presentation, we will delve into the code and explain each component of our neural network program. Moving on to the neural network architecture, our model consists of an input layer with 2 neurons, a hidden layer with 2 neurons, and an input layer with 1 neuron. We have opted for the sigmoid activation function of the hidden layer. Our data set comprises input X and output Y data. Specifically, X contains 2 input features, namely future 1 and future 2, with 4 data points. Y holds the corresponding output labels. Inputs, we import the necessary libraries like NumPy, Pandas, and the Matplotlib for handling the data for input and output. We define the data using array, that NumPy and NumPy array, and then we initialize the data. The data stores in various parameters like input and output. M for number of training examples, LR for learning gradient designs, NP random seed that uses setting the random seed for reproducibility. First, we initialize the weight, that is random in, and we lost the storage, like create an empty list losses to store the loss values during training. During the training phase, our neural network undergoes an interactive process to learn from the data. This process involves forward propagation to compute predictions, loss computation using the cross entropy function, backward propagation to compute gradients and weight updates via gradient design. To monitor the training process and assess the model performance, we plot the data values in Matplotlib. Visualization understands how effectively our network is learning and improving the predictions over time. We use sigmoid activation function which maps any real valued number to the range. We define sigmoid and forward propagation. Forward propagation is used to compute activation of the hidden and output layers based on the input and current weights. Back propagation defines the function which computes gradient and for the loss function with respect to the weights using the chain rule. In the line, the np dot is dz2 a1 dz1. It defines the back propagations. In training loop, iterate over a fixed number of iterations for training the neural network. Forward propagation and loss computation, compute forward propagation to get predictions and then calculate the loss using cross entropy. We have to update the weight using the gradient design. The loss visualizations, plot the values using Matplotlib to visualize the training process. We use the visualization tool loss. We have to predict the function using the training model, so we use define predict. Our model is trained, so we test by making predictions on the new data points by showcasing predictions for our 4 sample test cases and prediction definition. Make predictions for the sample test cases and print the inputs along with the predicted outputs. We have predict the input output and test the array using the numbers 1 0 1 1. The input w1 w2. We have the outputs. Thank you for listening. Experiment 3 finishes off.